January 15, 2022. A normal day for most of humanity, a quiet Saturday unfolding across time zones. Then, without warning, the Earth suddenly spoke. It was a sound so massive, so overwhelmingly powerful, that its reverberations circled our entire planet not once, but 6 times. A pressure wave of such pristine clarity and immense force that it left scientists around the globe staring at their instruments in utter disbelief. This wasn't just another seismic event. It was an anomaly. Even now, years later, the full scope of its extremity and the precise reasons behind its unprecedented power remain shrouded in scientific mystery. Welcome to Cosmic Enigma. This is the profound and perplexing mystery of the Tonga sound explosion. Please subscribe to this channel, like this video, and leave a comment below about what you think of the Tonga sound explosion. Let's dive into this extraordinary event together. Off the coast of Tonga, in the tranquil South Pacific, sat a sleeping giant, the Tonga Ha'apai volcano. On that fateful day, it woke up with an unimaginable fury, erupting violently from beneath the ocean's surface. Satellites orbiting above captured the initial moments of this cataclysm. A massive white dome of superheated steam and ash erupted from the ocean, expanding outward like a shockwave frozen in time. The plume was so vast, so immense, it could be seen clearly from space, a colossal cloud that swallowed the horizon. But the sound, or rather the pressure wave it generated, was something entirely different. It transcended the visual spectacle, becoming a global phenomenon. All around the world, from the bustling cities of Japan to the remote shores of Portugal, from the icy expanses of Alaska to the vibrant landscapes of South America, sensitive instruments registered the same unmistakable signal. It was a powerful low-frequency pressure wave traveling relentlessly across the globe. This atmospheric wave circled the Earth with astonishing precision. Not just once, as many powerful events might, but an unprecedented 6 times, each circuit a testament to its enduring energy. It was as if our entire planet had momentarily become a massive, resonating bell, struck by an unseen hammer, its vibrations echoing through the very air we breathe. The sheer scale of this planetary reverberation was unlike anything witnessed in modern history. Volcanic eruptions are inherently loud, often producing thunderous roars and explosive blasts. However, the Tonga event defied all expectations, seemingly breaking the established rules of physics in ways scientists still struggle to fully explain. 3 distinct features made this atmospheric phenomenon almost otherworldly, setting it apart from any other recorded event. First, it behaved like a global sonic boom. Imagine the sharp crack of a jet breaking the sound barrier, but scaled up to encompass an entire planet. This was a shockwave that didn't simply dissipate, it maintained its integrity, relentlessly propagating across vast distances. Second, distance didn't seem to matter. Normally, sound energy weakens dramatically as it travels, fading into the background noise over long distances, yet this wave held its strength with astonishing persistence, traversing entire oceans and continents. It arrived thousands of kilometers away from its source with remarkable clarity, almost as if the explosion wasn't a localized event but was happening everywhere simultaneously. This sustained power challenged conventional understanding of atmospheric wave propagation. Third, and perhaps most paradoxically, people barely heard it, yet the Earth profoundly felt it. In many countries directly in its path, individuals reported hearing nothing unusual, their ears oblivious to the colossal energy passing through. Yet scientific instruments, designed to detect the most subtle atmospheric shifts, recorded a razor-sharp, undeniable signal. It was as if this immense sound was directed not at our human ears, which are tuned to a specific frequency range, but at the planet itself, causing it to resonate. The Earth vibrated like a giant cosmic bell, responding to a force that bypassed our immediate perception, but left an indelible mark on global sensor networks. This disconnect between human experience and instrumental data only deepened the mystery. The Tonga eruption triggered a LAM wave, an incredibly rare type of atmospheric wave. These waves travel around the globe with almost no energy loss, behaving as if the atmosphere itself vibrates as a single, unified shell. We have only ever seen clear evidence of such a phenomenon once before in recorded history, following the cataclysmic Krakatoa eruption of 1883. That event sent atmospheric waves around the world multiple times, a testament to its power. However, even Krakatoa, a benchmark for volcanic intensity, didn't produce a lamb wave as clean, as perfectly formed, and as globally coherent as the one generated by Tonga. The precision and persistence of Tonga's lamb wave were unprecedented. This suggests a unique set of conditions or an unknown mechanism that allowed for such efficient energy transfer into this specific atmospheric mode. Understanding this efficiency could unlock new insights into atmospheric dynamics. Scientists possess sophisticated models to calculate the energy released by volcanic blasts, often correlating it with seismic activity and plume height. However, the Tonga eruption simply doesn't fit into any of these established models. The atmospheric pressure wave it generated was significantly stronger than expected, far exceeding predictions based on the eruption's estimated size and seismic signature. This discrepancy points to a profound puzzle. It's as if an extra, unknown source of energy contributed to the blast's atmospheric impact, a component not accounted for in our current understanding of volcanic processes. This suggests a missing piece in the physics of extreme eruptions. The sheer magnitude of the atmospheric pressure wave, disproportionate to other measurable aspects of the eruption, indicates a process we don't yet fully comprehend. It challenges our fundamental assumptions about how volcanoes release energy into the atmosphere. The eruption plume from Hunga Tonga Hunga Hapai shot an astonishing 58 kilometers into the sky. This incredible altitude propelled material far beyond the stratosphere, deep into the mesosphere, a region rarely disturbed by terrestrial events. No volcano in recorded history, not even the most powerful eruptions of the past, has ever pushed material that high into Earth's atmosphere. This unprecedented height alone makes Tonga a geological outlier. But how could one explosion convert so much energy into both an atmospheric pressure wave and such an extreme vertical thrust? Why this particular volcano, and why at this exact moment did it achieve such an extraordinary feat? Current scientific models struggle to completely explain this combination of extreme plume height and global pressure wave. The mechanisms behind such efficient energy partitioning remain elusive. And that's what makes this event feel in some ways almost extraterrestrial in its scale and its defiance of our expectations. It pushes the boundaries of what we thought possible for Earth's geological forces. The leading theories attempting to explain Tonga's extraordinary power point to a rare and potent combination of factors: the presence of vast amounts of seawater, immense pressure, and trapped volcanic gases. Because the volcano was partly submerged, the interaction of superheated magma with cold ocean water may have created the perfect conditions for an extremely efficient and explosive shockwave. This phreatomagmatic interaction, where magma rapidly vaporizes water, could have amplified the blast's energy release into the atmosphere. The rapid expansion of steam would have acted like a piston, driving the pressure wave with incredible force. However, whenever researchers attempt to simulate these conditions, something doesn't quite match the observed data. The models consistently fall short of fully replicating the sheer magnitude and global reach of the actual event. Something is still missing from our equations, a crucial variable or an interaction we haven't yet fully accounted for. The precise physics of this unique underwater eruption remain a subject of intense investigation. And so we are left with one unavoidable conclusion. We still don't fully understand why this particular explosion produced the most powerful atmospheric pressure wave ever recorded. The Tonga Sound explosion stands as one of the great scientific mysteries of the 21st century. It is a profound reminder of the Earth's capacity for unexpected and awe-inspiring power, challenging our scientific frameworks and pushing the boundaries of our knowledge. The Tonga eruption reminded us that even in a world equipped with advanced satellites, powerful supercomputers, and intricate global sensor networks, the Earth still holds secrets. It possesses forces and phenomena we cannot yet fully explain, mysteries that lie just beyond our current grasp. And maybe that's the true beauty of it, because where mysteries exist, where the unknown beckons, wonder inevitably follows. It fuels our curiosity, drives our research, and inspires us to look deeper, to question more profoundly. If you enjoy diving into the strange and the unexplained, if you find fascination in the cosmic enigmas that surround us, then make sure to subscribe to this channel. Leave a like on this video and tell me in the comments which cosmic mystery you want to explore next. Thank you for watching, and until the next enigma.